Today we are going to talk about factoring quadratic equations of a special case. These quadratic are of the form x² plus bx plus c. If you remember, the coefficient of x² is called the leading coefficient, and in this case the leading coefficient, which must be here, is 1. So these quadratic equations must have leading coefficient equal to 1. Now let's see how we can find a system of factoring these quadratic easily. Before we start talking about that one, let's expand a couple of binomial which are multiplied. Let's say the first thing is how to multiply x plus 2 times x minus 3. Again, as usual, I'm going to use the arrow method. I'm going to multiply x inside the second bracket and then multiply 2 inside the second bracket. What I'm going to get is x² minus 3x plus 2x minus 6. x² is by itself no like term. Negative 3x plus 2x gives me negative x, and then negative 6. So this is the first product. The second example asks us to expand x minus 4 times x minus 2. The same way, I'm going to multiply x within the second bracket and negative 4 again in the second bracket. I'm going to get x² minus 2x minus 4x, and then minus 4 times minus 2 gives me plus 8. Again, x² is by itself. Negative 2x and negative 4x give me negative 6x and plus 8. So this is the expansion of the second example. Now we are going to do a general product of two polynomials, x plus r times x plus s. Again, we are going to do the same technique. X times x gives me x², x times s gives me sx, r times x gives me rx, r times s gives me rs. Again, x² is by itself, but sx and rx, they have x in common, so I can take or factor out s. I can factor out x, so I'm going to get s plus r. And then rs is also by itself. So this is the expansion of example 3, which is the general expansion of a binomial of the form x plus r times x plus s. Just remember, r and s are numbers, or real numbers. Now, if we look at the result of these three expansions, you can see that there is a pattern here. First of all, if you look at all these products, the coefficients here are all equal to 1. And the coefficient of the result, the leading coefficient, is also 1. The other thing is that if you look at these constants, which are within the brackets, when you multiply them together, plus 2 times negative 3 gives you negative 6. Negative 4 times negative 2 gives you plus 8. R times s gives you rs. And also, going back to the first one, 2 plus negative 3 gives you negative 1. Negative 4 plus negative 2 gives you negative 6. And r plus s gives you r plus s here. So, the result is the following. If you remember, we said that the first step in any factoring is common factor. So after you do the common factoring, if the leading coefficient a, okay, is 1, then you are going to do what we call an sum and product method. In the sum and product method, we look at the quadratic, which is x squared plus bx plus c. And remember, b and c are real numbers. We are going to try to find two numbers that their product is c and their sum is b. If you can find those two numbers, then the factor is x plus r times x plus s, if r and s are those two numbers, that their product gives you c and their sum gives you b. Now, one thing you have to remember is that not all the quadratic expressions of this form, x squared plus bx plus c, are factorable. Some of them are not factorable, even with this method. For example, if we look at this quadratic x squared plus x plus 1, we can see that b is equal to 1, c is equal to 1. Now we have to find two numbers that they multiply to 1, add up to 1 too. So let's see what are those numbers. We know that if one is negative 1, the other one is negative 1, their product, which I showed with the star, is negative 1 times negative 1 is 1, and their sum is negative 1 plus negative 1 is negative 2, which is not 1. The other possibility is that if both of them are 1, then their product is 1, but 1 plus 1 is 2. And you can see that this is not factorable, because you can't find such two numbers that their product is 1 and their sum is 1. Now let's look at another example that we can find such two factors. If you look at this quadratic equation, we can see that b is 3 and c is negative 18. So we have to find two numbers that their product is negative 18 and their sum is 3. There is no special technique to find, these two numbers, unless you come up with a table of all these pair of numbers. For instance, we can say that if b is 3 and c is negative 18, the two numbers r and s can be, let's say, 1 and negative 18, because their product is negative 18, 2 and negative 9, 3 and negative 6, or we can have the reverse. We can have negative 1 and 18, negative 2 and 9, negative 3 and 6. Now if we look at the sum here, negative 18 plus 1 gives you negative 17, negative 2 plus 2, negative 9 plus 2 gives you negative 7, Negative 6 plus 3 gives you negative 3. Negative 1 plus 18 is 17. Negative 2 plus 9 is 7. And negative 3 plus 6 is 3. The only one which gives you this sum of 3 is negative 3 and 6. So we can say that this one is equal to x minus 3 times x plus 6. And if we expand it, x times x gives us x squared. X times 6 is 6x. Negative 3 times x is negative 3x. 6x negative 3x gives you 3x. And negative 3 times 6 gives you negative 18. Our last example is the following. We have been given a quadratic equation of the form x squared plus 5x plus 6, which represents the area of a garden. We need to find the dimension of the rectangular water garden. Since it's a rectangular, so the area is length times width. This means that we should try to factor this quadratic equation. Now, if you look at this quadratic, the leading coefficient is 1, A is 1, B is 5, and C is 8 and 6. So I should be able, hopefully, to find two numbers that their product is 6 and their sum is 5. After going through the different pairs using the table that we did in the previous example, such a two numbers can be equal to 3 and 2, because 3 plus 2 gives you 5 and 3 times 2 gives you 6. So I can write above equation as x plus 2 times x plus 3. Again, x times x is x squared, x times 3 is 3x, 2 times x is 2x, so 3x plus 2x is going to give you 5x, and 2 times 3 gives you 6. Now it says determine the dimensions if x represents 1 meter. So it doesn't matter which one we take as length or which one we take as width. So I can say one dimension is 1 plus 2 because x is 2, so it's 3. And the other one is 1 plus 3, which is going to be 4. So the dimensions are 3 meters and 4 meters.